So this is the 15th session on the topic music through MATLAB, and what we are going to do is to study the modified envelope function. Remember, envelope function generation we have already studied. What we are going to do in this session is how to modify that. Now the question we ask is why modification is required. Now in our earlier function it was necessary to use the equal function so that envelope would work properly. That means T is the array we supply as an input to the envelope function, and envelope is returned. So the number of samples must be same. So in our previous function this was not happening properly, so we used an equal function. So what we are doing is we are modifying the function so that equal is not required, and the returned envelope itself will have number of samples same as the number of samples in the input time array. That is why the modification. Now before we study the modified function, let us first of all revise our ideas of the envelope itself. So this is the entire duration of the envelope, starts from 0 seconds, goes up to 2 seconds. Remember, this essentially corresponds to the entire duration of the musical note. So in this particular case, it is shown to be 2 seconds, but it could be 1 second, it could be 0.5, 0.4, and so on. Now, what are the various phases in this envelope function? First of all, you have the attack phase where the envelope increases rapidly from 0 value to 1 value. So this is a small amount of time, and T1 denotes the number of samples in this phase, which is called as the attack phase. Then the next phase in the envelope is the small sustain phase, and the number of samples in this small sustain phase is equal to T2. Then you have decay, and again the number of samples in the decay phase is also equal to T2. These two need not be exactly same. In this particular case we are treating them as equal. Then you have the sustain phase, and finally the release phase, and release phase also has T1 number of samples same as the number of samples in the attack. Okay, so the function that we are going to write, we are giving it some name. So envelope T. So T is the input parameter to this function. So whenever you are going to call this function, it will be necessary to define T. So for calling the function, you first of all define the array T. So it starts from 0. This is the normal increment, and D is the duration of the time. So in this particular case it is 2 seconds, and as we have already said, it could be 1 second, 0.5, and so on, and then only you call the function. Alright, so let us now study the envelope function itself in detail, how to write the modified envelope function. So function en is equal to envelope T. Since T is already passed to the function, you calculate the length of T, which will tell you the total number of samples in the T. T1 is the number of samples, remember, in the attack phase and also in the release phase, and we say that it is 2% of the total time, so we write it as round of 0.02 multiplied by T. So remember, T1 is the number of samples in attack as well as release phase. Then we calculate T2, which we consider as 4%. Again, these values are not necessarily fixed. Someone may use a shorter attack phase, someone may use somewhat longer, and so on. But we have chosen the attack phase to be 2% of the total time, and T2, which is the number of samples in small sustain as well as decay, we are choosing 4% of the total number of samples. So what do? We calculate N1, that is length of T1. N2 is the length of T2. Then N3 is 2T1 plus 2T2. So this gives you total number of samples which are used in all phases except the sustain phase. So we now calculate the number of samples in the sustain phase, say T3. So that is equal to T minus N3. Okay. Then now you start generating your envelope. So linspace 0 to 1 T1, remember this is the attack phase. Then you have small sustain, so from 1 to 1 the number of samples is T2. L3, that is decay, so from 1 it decays to 0.9. Again, this 0.9 is a value we have used, but you can play with this. Someone may use 0.8, 0.7 and so on. So this is the decay phase. Then you have the sustain phase. So from 0.9 it remains more or less constant, but actually slowly decreases to 0.75. So if you want this to be exactly constant, then the last value can be 0.9 itself. It could be something else also, depending on the kind of the node that you are trying to produce. And finally you have the release phase. So from 0.75 it goes to 0. Okay. And then you concatenate all these values L1, L2, L3, L4, L5 and then return it. So A is given by concatenation of all this. So this is return En is equal to A. Remember, left hand side in the function is En, so it must be defined. So En is set equal to A and then that is returned. So this is your envelope function. So let us now study the main program which will call this function and then plot the envelope. So what do you do? So clear as usual, then d is equal to 2. So this is our duration of the envelope or duration of the node. Generate the t vector. Then you call the envelope function En. So En is now available and you just check that the length of t is same as the length of En. Okay, the way we have written the program, indeed they turn out to be same, but we are just checking it. And then you plot t versus En with an appropriate line width, and then as usual you say grid on x label time and the title envelope. Okay, so when you execute this main program, the calling program, then you get your output, that is the envelope. So in this particular session we have seen how to modify the old function so that equal function is not required, and that's all in this session.